Okay, well, good morning, everyone.
Good morning.
Good to see you all. Alrighty, so we have, let's kind of think about what we've done so far. We looked at a very popular FRQ for 2 straight days, right? Called accumulation problems. What type of problems? Classic problems, right? There's an amount coming in, there's an amount coming out, and then they can ask a bunch of things, such as, what is the amount at a specific time? How do you do that when they ask you how much is there, or what is the amount at a specific time? What do you do? You find the what? Ben? You find the integral of the rate. If it says how many people are coming in, the integral of that rate. How many people are going out? The integral of that rate. What else did they ask you for those FRQs? What were common things on the 4 FRQs that you did?
What's the minimum amount of people?
Minimum, and when is the minimum amount or maximum amount? So for that, you set the rate coming in minus the rate coming out equal to what number?
0.
Equal to 0, and then?
You take the first derivative.
You use the what?
First derivative.
The calculator, right? You see how, yeah, it's graphing calculator, don't you see? So you use the graphing calculator, you graph it, you see when it equals to 0, because that gives you the critical points. Once you have the critical points, what do? You plug the critical points into the amount function, and also compare it with what? Endpoints. And then you see everything, you can pick the maximum, minimum, whatever they want. What else would they ask? Oh yeah, they would also ask, is the amount increasing or decreasing at a specific time? How do you do that? Is the amount increasing or decreasing at a specific time? Like at time equals 5. What do you do with time equals 5? You plug it into the rate. And if you have rate coming in minus rate coming out, and that ends up being positive at time 5, that means that at time 5, what's happening to the amount? It's increasing. And if it's negative, then it's decreasing. So a bunch of things that you saw with that. And then yesterday we saw position. The derivative of position is velocity. The derivative of velocity is acceleration. Then we can go the other way as well. Okay, and so that's what we worked on yesterday. So today, we're going to look at something called separation of variables. What is it called?
Separation of variables.
All right, let's take a look here at what this is all about. So, do these two functions satisfy this equation? Well, I'm going to help you with the first one, and then you can answer part B. So, does this function satisfy this equation? Y double prime minus y equals 0. Well, I'm going to do this here up top. So for part A, first I need to find y prime. If this is y, what's the derivative of 4e to the negative x?
Negative 4e to the negative x.
Yeah, it would be 4e to the negative x times negative 1. Times negative 1, chain rule. But then this negative 1, I can put it on the front, and there is y prime. We agree? What about y double prime? Because that's what this is saying. Y double prime minus y equals 0. I just made this up, by the way, this one. There's nothing special about it. I just made it up, and I want to see if this satisfies this equation. So what is y double prime? Well, what's it going to be? Yeah, I think so, because I have negative 4. It's a constant, so doesn't really do anything. What's the derivative of e to the negative x? E to the negative x times negative 1, which makes this negative over here positive. Yay or nay?
Yeah.
Okay, so now I have y double prime, and now let me answer the question. Does does my original function satisfy y double prime minus y equals 0? Y double prime minus y equals 0, question mark? Let's see. I'm gonna plug it in. What's y double prime? 4e to the negative x minus, what's y? Is it 0? Yes or no? Yeah, they're the same thing. It will equal 0. Dling, 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 dling. So this means then that this function is a solution to this equation. This function is a what? A solution to this equation because it works. It made it true. We good? Okay. Well, now I want you to see if part B, y equals sine x, does it make this true? So go ahead and go through the process here. So find me y prime, find y double prime, plug it in, and see if it works. Okay, turn your partner please and kind of discuss, did it work? Yay or nay? Okay, is it a yay or a nay? So, what prime? That's so for this one, for y prime, let's go with Robert. What's y prime?
Cosine.
And what's y double prime?
Negative sine.
Okay, so when I try to test it, does this work? Let me see. Does y double prime minus y equals 0? It'll be negative sine x, right? Minus what? Sine x equals 0. Does it?
No.
No, it actually is negative 2 sine x. So, no. So this one, it would be yes, Cerritos. Finish it. Yes, Cerritos. There you go. You know you watch it. He's one of my sponsors on YouTube. And then we get negative 2 sine x equals 0. So this would be a no. Okay? So that just gives you a taste of what it means for something to be a solution to a differential equation. Mr. Lara, what's a differential equation? Well, I'm glad you asked. A differential equation is one that contains a derivative. So this equation here, did it have a derivative in it?
Yes.
Yeah, so it's a differential equation. Differential means comes from derivative. So it's an equation that has a derivative. And so this function here, does it have a derivative on the equation? I see a y prime, so it's a differential equation. Is this a differential equation here?
Yes.
I see a dy dx. dy dx is the same as what?
Derivative.
Yeah, I can replace it with what? dy dx is the same as what?
Y prime.
Y prime. So does it have a derivative?
Yes.
In the equation? Yes. So it's a differential equation. Okay? So our goal today is to find a solution. To find a what?
Solution.
A solution. The only thing is, when we usually think of solutions, we think of numbers. Like, oh, find the solution. Oh yeah, x equals 5. That was the solution. Oh yeah, y equals 2. We found the solution. But for a differential equation, the solution is not a number. It's actually a what? A function. Yeah, it's a function. So I'll say that again. For a differential equation, the solution is not going to be a number. It's going to be a what? Everybody, a what? A function. So our goal today is, when I give you a differential equation, is to find the function that makes it true. Okay? So by the end of today, you're going to be able to do that. And we're going to do that with a little something called separation of variables. What is it called?
Separation of variables.
Ooh, and you're gonna see what that means. So let's start off with the following. Ms. Carmen, should I go with the tougher one again, and then that way they'll be happy to see the easy one? No?
No.
Easy first?
Yeah.
All right. So we'll go to part B.
No.
Oh, you guys want to start off with something a little gnarly and then easy?
Yeah.
Yes, that's the
Oh,
whole.
it's fine to do that. All right. Well. So, separation of variables. Here is a differential equation. Now, why is this a differential equation? It has a y prime or a dy dx. We good? Okay. So the first way that you, the first thing that you do is you separate the variables. And I did that for you here already. Notice, the y, there's a y here. Now over here, they're on the same side. How did I make that happen? Think algebra. The dy stayed on the top. How did I bring this y to the other one? I multiplied both sides by what?
1 over.
By 1 over y. And boom, it showed up over here. Here I had an x. So what did I do to dx here at the bottom? Multiply both sides by dx. Now it's on the right side. I had an x squared plus 4 here. What did I do to both sides? Divide by x squared plus 4, and now it shows up over here. So notice the y's are with the y's and the x's are with the x's. Yay or nay? Yay. Notice also, you might say, wait, Mr. Lara, why didn't we bring the dy over here? Divide by dy. We always want the dy and dx to be on top. To be where? On top. I mean, remember when we did u substitution? We always wanted du to be on top, never at the bottom. So same thing here. We don't want dy at the bottom. We want it at the top. And same for dx. We didn't want it at the bottom. We now have it on the top. We good? Okay, so this, by the way, usually is an FRQ. It shows up as a part of an FRQ, and you get a point just for doing this part. So can we all do this algebraic part? Y's with y's, t's with t's, or x's with x's. Okay, so that's a point out of 9 points. We can all get that point. But why? Okay, what's next? Remember where we're heading. We're trying to solve for y. We're trying to solve for what?
Y.
For y at the end. Okay, that's where we're heading. We're trying to find a function. We're trying to find a what? A function that makes this true here. So what we do now, after we separate the variables, we're now going to take the antiderivative of both sides. Now the left side is very nice and easy. What's the antiderivative of 1 over y? ln. So it'd be ln. And to be proper, we're going to say ln of absolute value of y. And yes, there is a plus c that we usually put there, but I'm not going to put there now. I'll tell you why in just a moment. Okay, what about on the right side? Is it as easy as the one on the left? No, in fact, I think I'm going to need to use some of my powers that I got from the last chapter of doing an integral. Any ideas how can I find the antiderivative of this function? Use the calculator. You said use the calculator. Can you edit that out, please, Ms. Carter, when you're posting it? Embarrassing. Oh, don't embarrass me. But yes, if this is a calculator problem, absolutely, I would go for the calculator right away. But usually it's not. So I did hear another solution though. How can I find the antiderivative? Yeah, it's all about u. So we're gonna let u. We're gonna do this on the side. Let u is equal to oops, give it away. What should I make u equal to? X squared plus 4. And I have a feeling that I do a u substitution because what's the derivative of x squared plus 4? 2x, and I see an x here. And I can easily make it a 2x by putting a 2 there. So that kind of hints to me that it's a u substitution. Okay, so because the derivative of this one is kind of inside the function already. So let u equals x squared plus 4. du is going to equal to what? 2x dx. Okay, well, to make it work, I need to put what next to the x right here? A 2, but if I put a 2 here, what must I put on the outside? A 1/2. Okay, and so I'm taking a little detour here to do the u substitution. So this integral becomes 1/2 integral of what?
Du over u.
Yeah, do you see that at the top I have du? And at the bottom? U. Well, isn't that a lot nicer? What's the antiderivative of 1 over u? ln u. Plus c. We good? So now that I have that, I'm gonna bring that back over here, and I'm gonna plug in the x again. So the antiderivative of this ends up being 1/2 ln. What does u equal?
X squared plus 4.
And then plus c. We good? Okay. So I just took a little detour there, use substitution, but I'm back. I'm back here. All right, remember, the goal is to solve for what? What are we trying to solve for? For y. We're trying to get y by itself. Okay? Also, Mr. La, shouldn't there be a plus c here? Yes. But a plus c here, then it would combine with the other constant over here to make a new constant. So I only need to write it once over here. C. What can I do to this 1/2? Where could it go if it's a coefficient of a log? Where else could I put this one? As a power. Yeah. So ln. Guys, it's by the way, this is all algebra now. There ain't no more calculus being done. I already did the calculus, and this would be ln of x squared plus 4 to the 1/2, but x squared plus 4 to the 1/2 is the same as
X plus 2.
radical x squared plus 4. I mean, isn't that true? If I bring the 1/2 to the top as a power, x squared plus 4 to the 1/2 is the same as square root of x squared plus 4. Yes? And then there's still the plus c. I'm trying to get y by itself. What can I do to both sides to get rid of that ln? E. A big E. So then this disappears here, the E and the ln. Just like one direction, they go away. Oh, too soon? Too soon? And then I end up with this one. Now here I am going to do a little something different. So this is e to the power of this, of a sum. Would you agree with me that, I'm going to rewrite that this is the same as e to the ln of x squared plus 4 times e to the c. Write it down, take a moment and just analyze if it's true. So write it down, take a moment and just, and then not yes once you believe me. Are these two equivalent? When I multiply same base, what am I supposed to do with the exponents? Add them. Yes? But why did I break it up, Mr. Lara? Well, e to the, if c is a constant, then isn't e to the c another constant? So absolute value y is equal to e to the ln x squared plus 4 times a different c. And then what happens to e and ln? They cancel, so I get I'm going to put the c in front. So c radical x squared plus 4. Okay? Now, was I solving for y or the absolute value of y? For y. So I'm going to say, how do I get rid of the absolute value? Well, I say y is equal to plus or minus c x squared plus 4. Wait, Mr. How'd you get the plus or minus? Guys, if I ask you, like, if I tell you that the absolute value of x is 5, that means x is equal to what? 5 or negative 5. Yeah? So the same thing here, absolute value of y is equal to plus or minus what I just got. And I did it. I found a function that when I plug it in, it will make this true. Okay? Alright, let's take a look at questions about it. Ms. Cochran is like, I told you. I told you to do the second one first. You didn't listen to me. But the main thing is, separate the variables. Then you do the integral. And that might be the hard part, just getting the correct integral. After it's the integral, it's all algebra. Just find a way to solve for y. Find a way to solve for y. Okay? So let's go to the second one. It's going to be much simpler. You'll see. So this is e to the 4t y prime of t equals 5. Before I start, what's another way that I can write y prime of t? What is it? dy over dt. So let's write it that way. Okay? No, I haven't separated the variables. I just rewrote this in a way that's going to help me. Okay, take a moment and separate the variables, please. So put the y's with the y's and the t's with the t's. Well, to be honest, there's only one thing with a y in it, so just leave it alone. Okay, so get me that point on the AP exam, on the FRQ part. Separate that variable and you get a point. Okay, can you check with your partner, please? Go ahead and check with your partner, see if they have the same function that you have. So get the y with the y, the t with the t. Okay, then we check with our partner, please. Check with your partner. Okay, we got it? Still got it? So the dy should have stayed there. It's already on top. And then the 5, well, the 5 can go with either one, but I'll leave it there. And then it would be over what? E to the 4t. And then what about this dt? Right here, you multiply. Ta-da, now separated the variables. Raise your hand if you got that. Or something equivalent to it. Okay? Well, now why would I do that? Well, because now I can do what? Take the integral of both sides. Take the integral of both sides. Guys, what's the antiderivative of 1 dy? Y. Now this one, before I do calculus, I need to set it up. This is the same as 5 e to the negative 4t dt. Right? No calculus, I just rewrote it. Now I want to take the antiderivative, and I claim we can do it by just kind of doing the opposite of the chain rule. Here's the question: what function, when I take its derivative, gives me this? What function, when I take its derivative, gives me this back? That's the antiderivative. Work it out with your partner, please. What is the function that needs to be there that when I take its derivative, it's that? So go ahead and give me that, and then you're basically done with it. Hey, we got it? I didn't hear much talking. Turn to each other, please. If you have the shorter hair, tell your partner what you got. If you have the shorter hair, tell your partner what you got. Okay, what is the antiderivative of 5e to the negative 14? Talk to me. Negative 5 over 4 e to the negative 14 plus e. Do we agree?
Yes.
How many of us got that? Why? Because when you take the derivative, it becomes times negative 4. And so now I cancel with the 4 here to give me this. And that's it. Did we solve for y? Is y solved for? Show there. Did that one have algebra stuff that we needed to do? No, not really. Just that. We good? Questions about this then? Alright. Mr. Lara, I really like to solve for that C. Who said that? You would really like to solve for that C? Oh, that gives me a great idea. So,
solve for that C.
Solve for that C. So far we've done general solutions, but how about finding particular solutions? If I want to solve for that C, I would need a point. I would need a what?
Point.
Oh, well, look at the next example. What do I give you? A point. So we're going to do the same thing that we've been doing, but now for these, we actually can solve for the C if I give you a point that you can plug in. Okay? Let's take a look. So same thing, we're still practicing the same techniques. So finding functions so that this is true. We start out by separating the variables. So do that part real quick, please. This is an e. E to the negative t power. So that should take less than 20 seconds. Y's with y's, t's with t's. Do that right now. Y's with y's, t's with t's.
I swear I didn't see. No.
Oh, I see. You didn't see.
Mr. Laura back at
I
it
didn't
again.
get this.
But now we will see. We got it?
I see now.
You see it. All right. Let's see. Sarai, what'd you get? Okay. Do we agree? Raise your hand if you got that. If you got that. Guys, that's a point on the AP exam. That's a point on the AP exam. Right? The Y's with the Y's, T's or X's with X's or T's with T's. Okay? And perfect. That's awesome because now I can do what to both sides? take the integral. And now before we do the calculus, let's set it up and make it a little easier. Question for you guys. Is the antiderivative of 1 over y squared ln of y squared? No. That only works with 1 over y. 1 over y. But when it's 1 over y squared, I would need to rewrite it. And that's y to the negative 2 power dy. And I use the power rule. Okay. And then here the antiderivative e to the negative t dt. Okay, so I'm going to put an arrow here to continue right here. Alright, what's the antiderivative of y to the negative 2? What do we do to the power? You add a 1. So no more integral because I'm actually doing the antiderivative now. So it'd be y to the negative 1 over negative 1. Yes? No more antiderivative. On your test, some of you, even after you did the antiderivative, you still kept putting this little symbol. I know it's a cool symbol, but you gotta let go of it at some point. So when you do the antiderivative, you no longer need the antiderivative symbol. And then equals to, guys, what's the antiderivative of e to the negative t? Negative e to the negative t. And then here we will put a plus c. We good? Okay, let's keep solving for y. Let's keep solving for y. This becomes, I think this is the same as negative 1 over y. I mean, that negative is still there. And then y to the negative 1, isn't y to the negative 1 over y? That's how I got that. We good? Okay. And then this is equals to still negative e to the negative t plus c. Okay. How can I get rid of this negative? Multiply by a negative, so it'd be 1 over y is equal to positive e to the negative t minus c. What am I solving for again? Where am I going?
C.
True for c, but for right now I'm trying to solve for y. So I think I can put a 1 here. Right, there's always an over 1 there that we just don't use. You can either cross multiply, or there's a little trick in algebra. If you have two fractions, if you switch one, you have to do one with the other. Switch it. So I'm going to do that. And so I get y, or y over 1 is equal to 1 over e to the negative t minus c. Yes? This is where I would end on the previous example. That's how far we got, right? We solved for y, we have the c in there. But now they gave me a point. What can I do now? Plug in that point and solve for c. So now let's, what do I put for y? Using my point, what do I put for y? 1/2. 1 over e to the negative, what's that, x or t in this case? 0. What's e to the 0 power?
1.
And again, now we are solving for c. You can cross multiply if you like that. Or I'm going to use my trick again that I can flip one and flip the other. So I get 2 is equal to 1 minus c over 1 over 1. And I get 1 is equal to negative c, and therefore c is equal to negative 1. So my final answer, now that I know, it's going to be y is equal to 1 over e to the negative t, minus negative 1, which it would be a plus 1. So do you see it's the same thing that we did before? It's just we added an extra step. But everything else is the same. Okay? Most of it is algebra. Most of the problems that you have here are algebra problems, not calculus problems. Okay? So don't blame the calculus teacher, blame the algebra teacher.
I can finally see him.
Ah.
You
Love it.
You opened
Love
my
it.
eyes.
Yeah. Perfect. All right, so next one, find a function that satisfies this. Again, this is an e to the negative y sine x. So let's get that 1 point, yeah? 1 point out of 9. Get me the separate the variables. So let's do the first step. Let's separate the variable. Okay, so get the y's with the y's, the x's with the x's. Separate the variable. Okay, if you have the longer hair, check with your partner, please. If you have the longer hair, check with your partner, see what they have. You got it? Okay. Joshua, what you got? Dy over what, I'm sorry?
E to the negative y
Okay.
equals sine x dx.
We agree? Okay, raise your hand if you got that or something equivalent. Yeah. We just divided by e to the negative y and then multiplied by dx. Guys, that's a point out of 9. You don't understand how valuable that is. Every point counts. This is a free point that we can get basically. We good? Okay, now this sets up. Now, a lot of times I see it, every year is different, but sometimes the point is for trying to integrate. so just trying. So put a little integration symbol, letting the reader know that you know that's the next step. Like you know, okay, I separate the variables because I'm going to try to integrate. Okay? And then, of course, you usually get a point for having the correct integrals. You also get a point for having a plus C in your work. Even if everything else is wrong, you get a point for having a plus C. You guys are like, I got that point, Mr. Lyle. But you'd be surprised, a lot of you forget. Alright, so before I do the calculus, let's make sure it's nice and simple. Well, how else can I rewrite this? This is the same as what? E to the positive y dy. Okay? Do the next step, please. Actually, do the integration on both sides. Take the integral on both sides.
Sarah Van.
Sarah, not in this class. I mean, no. I'll take it.
Vincent.
Glad.
The brother's back here. Money.
Oh.
Okay.
Are you sure there's not like a Laura in there? No? Mr. Laura?
You just got stamped, bro.
Alright.
This Christmas comes in too, though.
You still have that?
For my people on the YouTube, you know I'm
You
very.
still have the ones I gave you.
I mean, it's sentimental power, guys. Like, I don't want to get rid of them. Because I don't get them every time, so like, they're special. It's a reminder. It's a reminder. I am appreciated. What's the antiderivative of e to the y?
E to the y.
E to the y. So, antiderivative of sine x. Cosine x.
Plus C.
If the people on the YouTube want to show appreciation, click here and send a donation. This copy, can you put that link there, please? Okay, go for it.
Calculus teacher needs to pay for his
These
expenses.
copy paper. We're running out, right, Ms. Cochran? Copy paper, we're running low? Yeah. All right. We good?
Yeah.
Is this what we have? Yes. Shame on you guys. Yes. See, you got me all riled up with the grams and all that. So it is negative cosine x plus c. Yes? Thank you. Good job. So, okay, now what?
I don't know.
How do I get rid of e? Because we're trying to solve for y.
Ln.
ln. Miss Cochran, can you believe this?
Maybe
These shenanigans.
Hey, it's gonna get you views though.
So there it is. Okay, so that's what we got for example 1. We were able to get that far. But now they give us a point. So what do I do with that point? Plug it in. So go ahead and plug it in. Plug it in and see if you can get the c value. Hey, Mr. Lara is appreciated for the people on the YouTube. That proof. Hey, we got it? Check with your partner, please. Check with your partner.
What's that?
Yeah, no, I know it.
How much was it?
Guys, what's that cosine of pi over 2?
0.
So we got ln c. How do I get rid of ln?
E.
And we get c is equal to
E over 2.
e to the 1/2. And there it is. So our final answer is going to be y is equal to ln negative cosine x, and then plus e to the 1/2. We good? Okay, so just one little extra step. Now, let's take a look at the next one. And the next one, there's something that it teaches you about the plugging in part. So let's go for it right off, and then you're gonna see that it becomes a little different. Find the solution of this initial value problem. Okay, so we got the differential equation. The what? Everybody, the what? Differential equation, because it has a derivative and they give us a point. All right, so we know how to start it. So we start by doing what to the variables? Separate the variables. I mean, that is the title of the notes. So that is what I want you to do. Separate the variables. So go ahead and do the first step. Separate the variables.
It's kind of.
What's on yours? I forgot I erased it on mine. Yeah. Okay, so it's already there. It's already there. You guys are good.
Teacher copies, guys.
You guys are good. So, okay, well, you can see on your handout. You can see on your handout that dy I know stays here because it's on the top. So cosine y dy, I'm happy about it. So really, the only thing I got to do is what? Move the dt over, and then there's your 1 point on the AP exam. So cosine y dy is equal to sine squared t cosine t dt. We good? Separated the variables. Nice. All right, now what? What should I write now?
Integral.
Integral. Integrate.
Try to integrate.
Try to integrate. What's the antiderivative of cosine y? Forgive me, Father, for I have signed. Good? Sorry, not sorry. All right, and then we're going to say this one, though. It's not as simple as this one. Ideas?
You.
It's all about you. So we're going to... Okay, turn to your partner. If you have the short hair, what is u going to equal and why? Turn to your partner. What is u going to equal and why?
Sine. Because it beats weird. It's like, oh,
You got it? Okay, so what does u equal? Sine of t. Why? Because we get cosine t dt. And cosine t dt is here. So, oh, no.
Teachers, please excuse the interruption. At this time, LPAC system is down. LPAC system is down. Please do not send any students for testing at the beginning of fourth period.
hey, yo.
Please do not send students for testing fourth period. Thank you.
Okay, so u squared du. What's the antiderivative of u squared?
U cubed over 3.
U cubed over 3, and then plus c.
Yes.
So I'm ready to bring it back. And I'm going to plug in the sine t back on. So it'd be sine what? Cubed of t over 3 plus c. We good? All right. At this point, though, we're a little stumped because remember, we're trying to solve for what? For y. And what this problem is trying to teach you is the following. You don't need to wait till the end to plug in the point. You can plug in the point early on. So why don't we plug in the point now and try to solve for c? So let's do it. So it's going to be sine. And then what is the y value? Pi over 6 equals to sine cubed of 0 over 3 plus c. So I plugged it in right now. But Mr. Laura, you haven't solved for y yet. I can do this right now if I wanted to, and then I get what's sine of pi over 6? 1/2. What's sine of 0?
0.
And 0 cubed?
0.
0 over 3?
0.
So c is equal to 1/2. So watch this. I'm going to put an arrow here right before I plugged in. I already know what the c is. And so I'm going to say, so the function that works is this. Sine y is equal to sine cubed of t over 3. And then what is c? And this works.
How do you know?
So this is a function that works. Now, if they actually said solve for y, you just say y is equal to sine inverse of all of it, and then you're done. But if they don't say that it's gonna be y equals, this would work as well.
I can finally see.
We good? Okay, so separation of variables, guys. Separate like you've never separated before. Take that integral, solve for that c. All right?
Make sure to
Perfect.
subscribe.
Make sure to subscribe, and if you want to see more videos, click here, 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 or here. Bye-bye.